The thermometer outside Otto Schneider's cabin read 22 degrees below zero, and inside, despite a roaring fire that consumed half a cord of wood in 2 days, the temperature hovered at 19 degrees. 50 yards away, in a structure his neighbors had mocked as Vogel's metal coffin, Herman sat in shirt sleeves at 71 degrees, the small stove burning a single armload of kindling. Before we continue, drop a comment telling us where you're watching from, and if stories of frontier innovation fascinate you, hit subscribe because tomorrow's tale is even more unbelievable. The winter of 1886 arrived in the Colorado high country with unusual severity. By late November, snow had already accumulated to depths that typically didn't appear until January. Herman Vogel watched the drifts climb past his cabin windows and calculated wood consumption with growing concern. His cabin was well built by frontier standards, 2 logs thick at the walls, chinked with clay and moss, a stone fireplace that drew cleanly, and a roof that shed snow without leaking. He had constructed it himself 3 years earlier when Margaret agreed to leave Denver and try mountain life. The cabin measured 20 feet by 24 feet with walls 10 feet high, providing 480 square feet of living space. It had cost him $83 in materials and 3 weeks of hard labor with help from Otto Schneider, whose larger cabin sat just across the clearing. That winter, Herman burned wood with an intensity that shocked him. He had laid in 6 cords in September, considering himself well prepared. By mid-December he had consumed nearly 2 cords, and the coldest months still lay ahead. Each morning he woke to find frost on the interior walls, despite banking the fire carefully before sleep. Margaret wore 2 layers of wool clothing indoors. Young Klaus, age 5, played near the fireplace because anywhere else in the cabin felt painfully cold. The fireplace itself became a tyrant demanding constant attention. Let the fire diminish even slightly, and within an hour the interior temperature dropped 10 degrees. Herman found himself waking multiple times each night to add wood, stumbling half asleep to the woodpile, feeding the endless hunger of the flames. He wasn't alone in this struggle. Otto's family faced identical challenges. So did Wilhelm Hoffman and his wife and the dozen other families scattered through the valley. This was simply how winter worked in the high country. You burned enormous quantities of wood, you stayed as close to the fire as possible, you endured the cold in the outer regions of your cabin, and you waited for spring. No one questioned this reality. It was the price of mountain living, accepted as inevitable as snow itself. But in January of 1887, the cold intensified beyond normal bounds. Temperatures dropped to 20 below zero and stayed there for days. Herman's wood consumption became frightening. He was burning nearly half a cord per week, and still the cabin remained brutally cold. Margaret developed a persistent cough. Klaus's hands and feet were always cold to the touch, even when he sat directly before the fire. Herman added more wood, stoked the flames higher, and watched his carefully accumulated supply diminish with terrifying speed. By late January, he knew he would run short before spring. The choice became clear. Leave the mountains and abandon their homestead, or send someone down to the lower valleys to purchase more wood at winter prices that would consume their remaining savings. He chose the latter, making the 3-day round trip himself through deep snow, returning with another cord strapped to a borrowed sledge. It bought them time, but it didn't solve the fundamental problem. The cabin was defeating him, and Herman couldn't understand why. Klaus's cough worsened through early February. What had seemed like a simple cold developed into something more serious. His small body burned with fever, while the cabin remained cold despite the fire roaring constantly. Margaret tried every remedy she knew. Hot compresses, steam from boiling water, wrapping him in every blanket they owned. Nothing helped. On February 3, 1887, Klaus died in his mother's arms, his lips blue, his breathing simply stopping in the coldest hour before dawn. Herman held his son's body and felt something break inside himself that had nothing to do with grief alone. The boy had died in a cabin with walls 2 logs thick, with a fire that consumed wood faster than Herman could split it, with parents who had done everything possible to keep him warm. It wasn't enough. The cold had won anyway. They buried Klaus on a hillside 2 days later. The ground was frozen 18 inches down. It took Herman and Otto 4 hours to dig a grave deep enough. Margaret stood in the wind, wearing every piece of clothing she owned, and still she shivered violently. The cough that Klaus had died from was already growing in her chest. Herman knew what was coming. He could hear it in her breathing at night, see it in the way she moved slowly, conserving energy her body no longer possessed. He burned wood recklessly now, keeping the cabin as warm as he possibly could, but warm was a relative term. He managed to maintain 50 degrees near the fireplace. 10 feet away, the temperature dropped to 35. Margaret spent her days in a chair pulled close to the flames, wrapped in blankets, barely speaking. She died on February 9th, 6 days after Klaus. Her last words were that she was sorry for not being stronger. Herman buried her next to their son. He dug the grave alone this time, refusing help from neighbors who had come to pay respects. The physical labor kept him from thinking. When he finished, when Margaret was in the ground and covered with frozen earth, he returned to the cabin and sat before the fire for 3 days without moving except to add wood. He didn't eat. He barely drank water. He simply sat and stared at the flames, trying to understand how this had happened. Other families lost members to winter sickness. This was known. This was accepted as part of frontier life. But Herman couldn't accept it. His mind, trained in his youth by a German schoolmaster who had insisted on mathematical precision, kept returning to a simple question. Why had the warmth been insufficient? He had burned enough wood to heat 3 cabins by normal calculations. The walls were thick, the chinking was good, the fireplace drew properly, everything had been done correctly according to frontier building practices. Yet his family had frozen to death inside a structure specifically built to protect them from freezing. The logic didn't work. Something fundamental was wrong with how cabins were constructed, and Herman became obsessed with discovering what that something was. On the 4th day after Margaret's burial, he rose from his chair, found a pencil and paper, and began taking measurements. Herman measured everything: the interior dimensions of his cabin, the thickness of the walls, the square footage of the roof, the volume of interior space. He recorded outdoor temperatures 3 times daily using a thermometer Otto had loaned him. He noted indoor temperatures at 5 different locations throughout the cabin. He weighed the wood he burned each day and calculated its moisture content by comparing wet and dried samples. His neighbors thought grief had damaged his mind. Otto stopped by regularly, concerned, trying to draw Herman back into normal conversation. Herman showed him pages of figures: how many cubic feet of interior space, how many square feet of surface area losing heat to the outside, how many British thermal units required to raise 1 cubic foot of air 1 degree. Otto nodded politely and suggested Herman might benefit from visiting the pastor. Wilhelm Hoffmann, the community's best carpenter, came by to check on the widower everyone worried about. He found Herman on the cabin roof with a measuring tape, calculating the exact surface area of each plane. Wilhelm asked what he was trying to accomplish. Herman explained he was determining the relationship between interior volume and exterior surface area. Wilhelm said that wasn't how cabins were built. You built them big enough for your family and strong enough to stand up. That was all that mattered. Herman thanked him for his concern and continued measuring. By March, Herman had filled 2 notebooks with observations and calculations. He burned 400 pounds of wood per week on average to maintain an interior temperature of 45 degrees when exterior temperatures averaged 15 degrees. His cabin's interior volume was 4,800 cubic feet. Its exterior surface area, including roof, was approximately 1,600 square feet. He compared these numbers to information he gathered from neighbors about their cabins. Otto's cabin was larger, 24 feet by 28 feet. It required 550 pounds of wood weekly to achieve similar interior temperatures. Wilhelm's cabin, smaller at 16 feet by 20 feet, burned 300 pounds weekly. Herman began to see a pattern. The amount of wood burned wasn't proportional to interior volume. It was proportional to surface area. A cabin twice as large didn't need twice as much heat. It needed less than twice as much because the volume increased faster than the surface area. But even more significant, all cabins, regardless of size, were losing heat at rates that seemed excessive. Herman calculated that his cabin surface area was losing approximately 30 British thermal units per hour per square foot, with a 30-degree temperature difference between inside and outside. That meant his cabin was losing 48,000 BTUs per hour. To replace that heat, he needed to burn wood constantly. The mathematics revealed something Herman found shocking. His cabin wasn't a shelter. It was a heat-consuming machine, taking every BTU he could generate and throwing it away through walls, roof, floor, and gaps he couldn't even see. The larger the cabin, the more surface area, the more heat lost. But even small cabins lost so much heat that keeping them warm required absurd amounts of fuel. There had to be a better approach, some way to build a structure that didn't waste heat so catastrophically. Herman spent April thinking about this problem with an intensity that worried everyone who knew him. By May of 1887, Herman had reached a conclusion that violated everything frontier culture believed about shelter. Bigger was not better. Bigger was worse. Every additional square foot of wall or roof was another surface losing heat. Every additional cubic foot of interior space was more air that needed warming. The mathematics were undeniable. To minimize heat loss, you needed to minimize surface area. To minimize heating requirements, you needed to minimize volume. The most efficient shelter would be the smallest shelter that could sustain human life. This idea was heretical. Cabin size indicated success, prosperity, and commitment to permanent settlement. A large cabin said you were building a future. A small cabin said you were poor, temporary, or defeated. Herman understood this cultural meaning, but he no longer cared. Margaret and Klaus were dead because he had built a cabin that couldn't keep them warm. Size had been irrelevant. Warmth was everything. He began sketching designs for a minimal shelter. His calculations suggested that a structure 10 feet wide and 20 feet long would provide 200 square feet of living space. That was less than half his current cabin's size. With an arched roof 8 feet high at the center, the interior volume would be approximately 1,200 cubic feet, 1/4 his current cabin's volume. More importantly, the total surface area would be dramatically reduced. An arched design, he calculated, would have approximately 650 square feet of surface area compared to his current cabin's 1,600 square feet. Less than half the surface losing heat, 1/4 the volume requiring heat. If his mathematics were correct, this tiny shelter would need 1/8 the wood to maintain the same interior temperature. Or alternatively, with the same wood consumption, it could maintain temperatures 60 degrees warmer. Herman shared this conclusion with Otto Schneider over coffee in late May. Otto listened carefully, examined the sketches and calculations, then shook his head. Herman was talking about a shelter smaller than some families' storage sheds. Where would firewood be kept? Where would supplies be stored? How would a man maintain his sanity living in such cramped quarters through a 6-month winter? Herman answered each objection with mathematics. Firewood requirements would be 1/8 of current amounts, so less storage was needed. Supplies could be stored vertically using hanging systems and shelves. Sanity was preserved by warmth. Freezing to death in a spacious cabin seemed worse than surviving comfortably in a small one. Otto called the idea interesting but impractical. He wished Herman well, but suggested maybe returning to Denver would be healthier than staying alone in the mountains with these strange notions. Wilhelm Hoffman was less diplomatic. When Herman showed him the designs, Wilhelm laughed openly. This wasn't a cabin. This was admitting defeat, admitting you couldn't survive like a real mountain man, admitting you needed to hide in a tiny box like a frightened animal, Real men built real cabins. Herman asked if real men let their families freeze. Wilhelm stopped laughing, but his expression made his opinion clear. Herman Vogel had been broken by grief and was no longer thinking properly. Herman traveled to Denver in June of 1887. The trip took 4 days by horseback, following established trails down through the mountain passes into the lower country. Denver had changed dramatically since he and Margareta had left 3 years earlier. The city was growing rapidly, with new buildings rising along every major street and warehouses expanding near the railroad terminus. Herman had no interest in the city's growth. He came looking for specific materials that weren't available in the mountain settlements. He found what he needed at a supply warehouse near the rail yards: corrugated metal sheeting, newly manufactured in eastern factories and shipped west by train. The material was being used primarily for warehouse roofs and industrial buildings. The warehouse manager seemed confused when Herman requested sheets sized for a small residential structure. Most buyers wanted metal for barns or storage buildings, not living quarters. Herman didn't explain his purpose. He simply ordered 32 sheets of corrugated galvanized steel, each sheet 8 feet long and 2 feet wide. He also purchased specialized fasteners designed for metal construction, rolls of tar paper, bags of sawdust from a lumber mill, and various small hardware items. The total cost was $93, most of his remaining savings. The warehouse manager arranged shipping to the nearest mountain freight station, 40 miles from Herman's cabin. Herman would need to make multiple trips with a borrowed wagon to haul everything to his building site. The manager asked what Herman was building. Herman replied that he was constructing an efficient shelter. The manager shrugged and processed the order. Denver merchants had seen stranger requests from mountain men. Herman returned to the high country in late June and began arranging transportation for his materials. Otto Schneider loaned him a wagon and helped with the first haul from the freight station. During the long day of loading and the 2-day journey back to the cabin, Otto asked careful questions about Herman's plans. Herman explained the basic design: an arched structure using corrugated metal as the exterior shell with wooden framing and insulation inside. Otto examined the metal sheets, noting their strength and light weight. He asked about winter conditions. Wouldn't metal be cold? Herman explained that metal itself was neither warm nor cold. It was simply conductive. With proper insulation between the interior space and the metal exterior, the conductivity became irrelevant. The metal's purpose was to provide a weatherproof shell that could be formed into an efficient arch shape. Otto remained skeptical but admitted the materials were interesting. When they reached Herman's property and began unloading, several neighbors came to watch. Wilhelm Hoffmann picked up a sheet of corrugated metal and laughed. Vogel was building a storage shed, apparently, a fancy one with expensive metal, but still just a shed. Herman didn't correct him. He stacked the materials carefully near his chosen building site and began planning the construction sequence. By mid-July, word had spread through the small mountain community that the mad German was building something strange with metal sheets hauled from Denver. Most assumed it was a large storage building or perhaps a workshop. No one believed Herman intended to live in whatever he was constructing. That misconception would last until the structure began taking recognizable shape. Herman began construction in late July. The first task was clearing and leveling the building site. He chose a location 50 yards from his existing cabin, on slightly elevated ground with good drainage and clear sight lines. The orientation was calculated carefully. The structure would face south to maximize winter sun exposure on the entrance. The prevailing winter winds came from the northwest. The curved shape would deflect wind rather than present a flat surface for it to push against. He marked the perimeter using stakes and string, forming a rectangle 10 feet wide and 18 feet long. Every dimension had been calculated and recalculated over the previous months. The foundation came next. Herman dug a trench 6 inches deep around the perimeter, filled it with gravel hauled from a nearby creek, and tamped it firm. On this base, He laid flat stones, creating a level foundation that would prevent ground moisture from reaching the wooden frame while providing thermal mass to moderate temperature swings. Most mountain cabins had no foundation at all, their logs sitting directly on the ground. Herman's approach was unusual, and neighbors who stopped to watch commented on the excessive effort for what they assumed was a storage building. The wooden frame was constructed from milled lumber Herman had purchased in Denver, along with the metal. He could have used logs, but logs were irregular and would create gaps in the curved structure. Milled 2-by-4-inch boards could be shaped into the precise arch he needed. He began by erecting vertical wall studs 16 inches apart around the perimeter, each stud 4 feet tall. These formed the lower walls. From the top of these walls he installed curved ribs that formed the arch, each rib cut from long boards that he steamed and bent into shape. The process was labor-intensive, requiring heating water in a large trough, steaming each board until it became flexible, then bending it carefully into the calculated curve, and bracing it until it dried in position. Wilhelm Hoffmann stopped by during this phase and studied the curved ribs with professional interest. The carpentry was competent, he admitted. The curves were consistent and properly braced, but he remained baffled by the purpose. Why create an arched roof for a storage shed? A simple peaked roof was easier to build and shed snow just as effectively. Herman explained that the arch eliminated corners and created the maximum interior height with minimum surface area. Wilhelm considered this, then shook his head. Herman was overcomplicating simple construction. Traditional methods existed because they worked. By late August, the frame was complete. The structure's skeleton revealed its unusual shape clearly now. The arched profile looked strange compared to the rectangular cabins that dotted the valley. Children from neighboring families came to stare at Vogel's barrel house, as they had begun calling it. Herman paid no attention to the mockery. He was focused on the next phase, insulation and interior sheathing. He had purchased enough tongue and groove boards to create a complete interior shell. Between this interior shell and the exterior metal, he would pack sawdust insulation. The sawdust, obtained free from a lumber mill during his Denver trip, would create dead air spaces that prevented heat transfer. This insulation approach was known in formal construction, but rarely used on the frontier, where cost and labor mattered more than thermal efficiency. As Herman installed the interior sheathing through September, the community's curiosity transformed into open mockery. The structure's small size became apparent once the interior walls were in place. 10 feet wide, 18 feet long, 8 feet tall at the center. It was tiny by any standard, smaller than most families' storage sheds, barely larger than an outhouse if you consider the only floor space. Ernst Bauer, visiting with his teenage sons, walked the interior perimeter in 12 paces and laughed. A man could barely turn around in here. Where would furniture go? Where would supplies be stored? How would anyone live in such a cramped box? Herman explained patiently that the small size was intentional, that thermal efficiency required minimal volume. Ernst shook his head and walked away, telling his sons this was what happened when grief broke a man's mind. You started building crazy things that made no practical sense. The name Vogel's grave began circulating. The structure did resemble a burial vault with its arched shape and small size. Children whispered that Herman was building his own tomb, planning to join his dead family. Their parents didn't correct this speculation. The structure was morbid, everyone agreed. It looked like something you'd bury things in, not live in. Otto Schneider remained more supportive than most, but even he expressed doubts when Herman began installing the metal exterior in early October. The corrugated sheets attached to the wooden ribs with specialized screws, each sheet overlapping the previous one to create a weatherproof surface. The metal rang when struck, creating hollow sounds that made the structure seem insubstantial. Otto pointed out that metal would be freezing cold in winter. Herman explained again about insulation and thermal barriers. Otto nodded but looked unconvinced. He suggested quietly that Herman might want to keep his old cabin available as backup when winter proved this experiment unworkable. Wilhelm Hoffmann was less gentle. He arrived one afternoon with 3 other men from the community, ostensibly to check on Hermann and his progress, but actually to make their opinions clear. Wilhelm announced that he would bet Hermann $5 that he wouldn't last one winter in this metal box. The others laughed and agreed. Hermann would be back in his old cabin by January, assuming he didn't freeze first. They called the structure various names: the tin coffin, Vogel's metal grave, the German's folly. Hermann accepted their mockery without argument. He had stopped trying to explain his reasoning to people who didn't want to understand mathematics. By mid-October, the exterior was complete. The structure stood finished, its corrugated metal surface gleaming dully in the autumn sun. It looked alien among the log cabins that surrounded it, like something that had fallen from the sky or been placed there by mistake. Parents warned their children not to play near it. The general consensus was that Hermann Vogel had built something strange and probably dangerous, and the coming winter would teach him the folly of rejecting traditional wisdom. Hermann heard these opinions and returned to work on the interior, installing his carefully planned systems for living in a space most considered uninhabitable. The interior construction required as much precision as the exterior shell. Hermann began with the insulation system, the critical barrier between the living space and the metal exterior. He had hauled 12 large sacks of sawdust from Denver specifically for this purpose. Sawdust was an excellent insulator when kept dry, creating thousands of tiny air pockets that prevented heat transfer. Between the interior tongue and groove boards and the wooden ribs that supported the metal exterior, he had created a cavity 4 inches deep. Into this cavity, he packed sawdust methodically, working from bottom to top, tamping it firmly to prevent settling while ensuring it remained loose enough to maintain its insulating properties. The process took 3 weeks. Every section had to be filled completely before the next section of the interior sheathing could be installed. Any gaps would create thermal bridges where heat could escape. Hermann worked with obsessive attention to detail, checking each cavity multiple times before sealing it permanently. The sawdust insulation created an R value approximately 3 times better than standard log walls. Combined with the minimal surface area of the tiny structure, the insulation would reduce heat loss to levels no conventional cabin could achieve. The floor required special consideration. Cold rising from the ground could negate all his other thermal efforts. Hermann laid down a vapor barrier of tar paper directly on the stone foundation, then constructed a raised floor using 2 by 6 inch joists. The space between the joists he filled with more sawdust insulation. Over this he installed tongue and groove flooring, creating a surface 18 inches above the stone foundation. The air gap and insulation combination would prevent ground cold from penetrating the living space. The stove placement was calculated with mathematical precision. Hermann positioned a small cast iron stove not in a corner, as was traditional, but near the center of the structure, slightly toward the rear. This location allowed heat to radiate in all directions rather than being blocked by walls. The stovepipe extended straight up through the arched roof at the highest point, creating maximum draft while minimizing the pipe length that would lose heat before reaching the exterior. He fabricated a metal shield around the stovepipe where it penetrated the roof, preventing any possibility of fire while allowing easy installation and removal if repairs were ever needed. Ventilation concerned him. A sealed structure would accumulate moisture and smoke. He installed 2 small vents near the floor at opposite ends of the structure, allowing cold air to enter and flow toward the stove. Near the peak of the arch, he installed an adjustable vent that could be opened or closed depending on conditions. This created a convection current. Cold air entered low, warmed by the stove, rose naturally, and either circulated in the curved space or exited through the high vent. The system was self-regulating, requiring no mechanical assistance. By early November, the basic systems were complete. The structure was weatherproof, insulated, and equipped with controlled ventilation. What remained was making the tiny space livable through intelligent interior design and space utilization. Herman had sketched plans for this phase during the summer. Every inch would serve multiple purposes. Nothing would be wasted. The interior space measured 180 square feet of floor area, with 8 feet of headroom at the center, tapering to 4 feet at the walls. Most people saw this as impossibly cramped. Herman saw it as a three-dimensional puzzle requiring creative solutions. He began with the sleeping area, which would occupy the rear third of the structure. Rather than placing a bed directly on the floor, he built a platform 18 inches high that spanned the full 10-foot width and extended 6 feet from the rear wall. This platform served triple duty. The top was his sleeping surface, the space beneath provided storage for winter clothing and bedding, and the platform's mass would absorb and release heat, moderating temperature swings. The sleeping platform's edges were finished with hinged panels that could be opened to access the storage beneath. Herman had calculated that he could store enough clothing, blankets, and personal items in this space to eliminate the need for a separate wardrobe or chest. Above the sleeping platform, he installed shelves that followed the curve of the wall, creating storage for books, small tools, and supplies. These shelves were accessible from the sleeping surface, allowing him to reach items without needing to walk to the rear of the structure. The middle section of the interior, approximately 8 feet of length, contained the living area and stove. The stove sat on a stone base that extended 2 feet on all sides, providing both fire protection and thermal mass. This stone absorbed heat during the day and released it slowly at night, reducing temperature fluctuations. Immediately adjacent to the stove, Herman built a narrow counter for food preparation. The counter was 30 inches deep and 4 feet long, constructed from a single plank that could be lifted and secured against the wall when not needed, creating additional floor space. Along the opposite wall from the counter, he constructed a fold-down table attached to the wall with heavy hinges. When lowered, the table provided a workspace 2 feet deep and 4 feet long. When raised and secured with a simple hook, it became nearly invisible, leaving the floor clear. Beneath where the table hung, he built a bench that served as both seating and storage. The bench lid lifted to reveal space for tools, maintenance supplies, and the items needed for daily living. The front section, nearest the door, served as the entry area and additional storage. Herman installed hooks at varying heights along the curved walls for hanging coats, hats, and equipment. He built a narrow boot bench beside the door with storage underneath for outdoor gear. Above the door, he constructed a shelf for items needed when entering or leaving: gloves, scarves, a lantern. Every vertical surface carried storage. The curved walls that would have been wasted space in a conventional cabin became useful through careful shelf placement. 2 windows provided light and prevented the claustrophobic feeling that concerned his critics. Herman positioned them at eye level when seated, one on each side wall, each measuring 12 inches by 18 inches. The windows were double-glazed, a technique he had observed in Denver buildings, with 2 panes of glass separated by an air gap that reduced heat loss while maintaining transparency. Herman understood that physical warmth alone wouldn't ensure survival through 6 months of mountain winter. The psychological challenge of living in 180 square feet could be as dangerous as cold if it led to despair or irrational decisions. He approached this problem with the same methodical thinking he had applied to thermal engineering. The curved ceiling, he recognized, could either feel oppressive or liberating depending on how it was treated. He painted it white using lime-based paint purchased in Denver. White reflected light, making the space feel larger and brighter. The curve itself, painted uniformly, created a sense of openness rather than the boxed-in feeling of flat ceilings with visible corners. Light was critical. Beyond the 2 side windows, Herman installed a small skylight at the peak of the arch. This circular opening, only 8 inches in diameter and covered with glass, allowed daylight to enter from above, even when snow covered the side windows. The skylight transformed the interior during daytime, eliminating the cave-like darkness that would have resulted from side windows alone. At night, the skylight revealed stars, maintaining psychological connection to the outside world. He positioned a mirror on the wall opposite the door, angled to reflect the entry window and create the illusion of depth. The mirror was 18 inches square, salvaged from his old cabin. In the tiny space, it made a surprising difference, suggesting the interior extended beyond its actual boundaries. Herman had read about this technique in an article about ship cabin design where space was similarly constrained. Color choices throughout the interior were deliberate. The tongue and groove walls he left natural wood, which provided warmth and visual interest through the grain patterns. The floor he darkened slightly with linseed oil, creating contrast with the walls and making the space feel grounded rather than floating. The few pieces of fabric he included, curtains for the windows and a blanket for the bed, were deep red. The color provided visual warmth and psychological comfort during the monochrome winter months. Organization systems prevented the chaos that would make small space uninhabitable. Herman labeled storage areas and maintained strict discipline about returning items to their designated locations. In a large cabin, leaving tools or supplies scattered was merely untidy. In this space, disorder would be suffocating. He established routines for daily living, morning tasks performed in specific sequence, evening preparations following set patterns. The routines weren't about rigidity, but about creating mental structure that made the space feel manageable rather than constraining. Fresh air circulation, beyond its thermal purpose, served psychological needs. The adjustable vents allowed Herman to control stuffiness without sacrificing heat. Even in severe cold, he could crack a vent briefly to exchange air, preventing the stale atmosphere that would have made the space oppressive. The brief cold shock was preferable to the gradual suffocation of sealed confinement. By late November, the interior was complete and organized. Herman moved his minimal possessions from the old cabin, arranging everything according to his planned systems. He had created a space that defied conventional wisdom, smaller than anyone thought viable, yet designed with sufficient care to be genuinely livable. The final exterior details were completed in mid-November of 1887. Herman installed the door last, a carefully constructed piece that had taken him 4 days to build. The door was assembled from tongue and groove boards 3 inches thick, fitted so tightly that no light passed between them. He reinforced it with diagonal bracing on the interior side and hung it on 3 heavy hinges that Wilhelm Hoffmann had reluctantly agreed to forge for him. The door fit its frame with precision, requiring firm pressure to close, but sealing completely when latched. Weather stripping made from wool felt lined the frame, eliminating drafts. The total cost of the structure, including all materials hauled from Denver and local purchases, came to $137. This was substantially more than a conventional log cabin. Otto Schneider's cabin had cost approximately $80 in materials, though it required 2 men working together for 3 weeks to complete. Herman's tiny structure had consumed 2 months of solo labor, plus the expense of manufactured materials that were uncommon on the frontier. His neighbors considered this additional evidence of foolishness. Why spend more money and time to create something smaller and stranger than conventional construction? Herman didn't attempt to explain the mathematics of long-term fuel savings to people who had already decided he was mad. A conventional cabin required 4 to 6 cords of wood per winter at approximately $8 per cord if purchased. His calculations suggested the tiny structure would require less than 1 cord, saving $30 to $40 annually in fuel costs. Within 4 years, the additional construction cost would be recovered through fuel savings alone. This assumed he survived the first winter, which his neighbors openly doubted. He spent the last weeks of November moving completely into the new structure and organizing his systems for winter living. The old cabin he left standing, but empty, its door secured against animals. Some neighbors interpreted this as Herman maintaining a backup shelter for when the metal structure proved uninhabitable. In truth, Herman simply saw no reason to demolish a sound building. It might serve future purposes or house someone else eventually. The community's attitude toward Herman and his structure ranged from pity to mockery, with occasional touches of concern. Ernst Bauer stopped by in late November to invite Herman to Thanksgiving dinner with his family, an invitation motivated partly by genuine concern and partly by curiosity about whether Herman would still be alive by Christmas. Herman accepted graciously. At the dinner, surrounded by Ernst's large family in their spacious cabin, the children asked Herman if he was scared to sleep in the metal grave. He answered that he was not scared, that the structure was well built and would perform exactly as designed. The adults exchanged glances that clearly communicated their opinion. The poor German was delusional, broken by grief, and would likely freeze to death before spring. They were kind to him at dinner, the way people are kind to those they pity. Herman thanked them for their hospitality and returned to his tiny structure as the first serious snows of winter began to fall. December arrived with temperatures dropping steadily, and the testing period began. December brought snow and cold, but nothing yet approaching the severe conditions that would provide genuine tests of the structure's performance. Temperatures dropped to 10 degrees above zero at night. Rising to the mid-20s during the day, light snow fell intermittently, accumulating to 18 inches by mid-month. Herman settled into his routines, learning the rhythms of living in such compact space while monitoring the structure's thermal behavior with careful attention. Each morning he recorded interior and exterior temperatures in a notebook. He noted wood consumption, stove management practices, and any observations about heat distribution or air quality. The small stove, which could hold perhaps 1/8 the wood of a conventional cabin fireplace, required feeding every 4 to 5 hours during the coldest parts of the day. At night, Herman loaded it carefully before sleep and found the interior temperature dropped only 6 to 8 degrees by morning. In his old cabin, overnight temperature drops of 20 degrees had been common. The difference was immediately apparent. The tiny structure held heat with remarkable efficiency. On days when he kept the stove burning steadily, the interior temperature stabilized at 65 to 70 degrees with what seemed like minimal effort. His neighbors, observing smoke from his small chimney pipe, assumed he was suffering, but too proud to admit defeat. Otto stopped by frequently during December, ostensibly to check on Herman's welfare, but actually expecting to find him miserable and ready to abandon the experiment. Instead, he found Herman comfortable, working on small projects, reading by lamplight, and showing no signs of distress. The interior, while undeniably small, was warm enough that Herman wore only a single layer of clothing. Otto's own cabin required him to stay dressed in wool and layers even when sitting directly before a roaring fire. Otto asked direct questions about Herman's experience. Was the space too cramped? Did he feel trapped? How was he managing with so little room? Herman answered honestly. The space was small, yes, but adequate. He had everything he needed within arm's reach. The warmth was excellent, better than he had experienced in years of mountain winters. The wood consumption was astonishingly low. He estimated he would use less than 1 cord for the entire winter. Otto listened, but remained skeptical. December was mild, he pointed out. Wait until January and February when temperatures dropped to 20 or 30 below zero. Wait until the real cold arrived. Other neighbors visited with similar expectations and departed with similar confusion. Wilhelm Hoffmann came by in late December, expecting to find Herman half frozen and ready to admit that traditional cabin construction existed for good reasons. Instead, he found the interior almost uncomfortably warm. the small stove radiating enough heat to make Wilhelm remove his heavy coat. Wilhelm examined the insulation visible where interior boards met the ceiling. He studied the stove placement and ventilation system. He admitted grudgingly that the structure stayed warm, but he maintained his prediction that severe cold would reveal fatal flaws in the design. Hermann accepted these visits and opinions without argument. He had no interest in convincing anyone of anything. The structure would prove itself, or it wouldn't. Words were irrelevant compared to measurable results. January of 1888 arrived with temperatures that tested both conventional cabins and Hermann's tiny structure. The thermometer outside Otto Schneider's cabin showed readings between 0 and 10 below zero for most of the month. Snow accumulated to depths exceeding 3 feet. Wind swept down from the high peaks, driving through every gap in conventional cabin construction. Otto's family, like all their neighbors, burned wood at rates that shocked them. Otto had laid in 7 cords in autumn, considering himself well prepared. By mid-January, he had consumed 3 cords and faced the real possibility of running short before spring. Inside Otto's cabin, despite fires that roared day and night, the temperature struggled to reach 45 degrees. The family wore multiple layers constantly. Frost formed on the interior walls each night. Water left in buckets froze solid. The children slept in pairs for warmth. This was worse than normal winters, but not unprecedented. Everyone suffered together and accepted suffering as the price of mountain living, except Hermann Vogel, whose tiny metal structure maintained interior temperatures that seemed impossible. Hermann burned approximately 12 pounds of wood per day throughout January. His supply, 1 cord cut and stacked in autumn, showed minimal depletion. The stove required feeding every 4 hours during the day, less frequently at night. Interior temperatures remained between 65 and 70 degrees with remarkable consistency. On the coldest nights, when exterior temperatures dropped to 15 below zero, the interior dropped to perhaps 62 degrees by morning. Even this reduced temperature was warmer than his neighbors achieved with massive fires burning constantly. The thermal mass of the stone stove base and the raised sleeping platform, combined with the minimal surface area losing heat, created stability that defied conventional expectations. Hermann could bank the stove at night, reduce it to coals, and still wake to reasonable warmth. His neighbors had to maintain active fires around the clock or face frozen cabins by morning. The difference in fuel consumption was dramatic enough that Ernst Bauer, observing Hermann splitting wood one afternoon, commented that Hermann must be spending all his time gathering wood from the forest. Hermann showed him the woodshed. 3/4 of 1 cord remained. Ernst did calculations in his head. His own family had burned 5 cords so far and faced another month of severe cold. Hermann had burned perhaps 1/4 cord in the same period. The difference was approximately 20 to 1. Ernst asked how this was possible. Hermann invited him inside and explained the physics again. Small volume, minimal surface area, excellent insulation, efficient heat distribution. Ernst listened more carefully this time, seeing the mathematics demonstrated through lived experience rather than theoretical predictions. He left thoughtful rather than mocking, though he didn't yet admit that Hermann had been right. Wilhelm Hoffmann maintained his skepticism despite growing evidence. He insisted that February would bring the real test, that January's cold hadn't been severe enough. Hermann nodded and continued his routines, recording temperatures, managing his stove, and living comfortably in a space that conventional wisdom declared uninhabitable. February of 1888 brought weather that silenced the remaining skeptics and transformed mockery into desperate attention. A high-pressure system settled over the Colorado Rockies in the first week of February and remained stationary for 9 days. Clear skies and still air allowed temperatures to plummet to levels rarely experienced even in the high country. The thermometer outside Otto Schneider's cabin registered 35 degrees below zero on the morning of February 7th. It would drop lower still before the cold snap ended. Otto's cabin, built to frontier standards that had served adequately for years, became nearly uninhabitable. The fireplace consumed wood at a rate that seemed impossible. Otto and his oldest son took turns feeding it throughout the night, unable to allow even brief gaps without watching the interior temperature plummet. Despite their efforts, the cabin's interior hovered between 18 and 23 degrees. Water froze in cups on the table. Bread left on a shelf became hard as stone. The family slept in a single bed, 3 children between the parents, everyone wearing every piece of clothing they owned, plus blankets piled so high that breathing was difficult. Wilhelm Hoffmann's family faced identical conditions. Ernst Bauer's situation was worse because his cabin, the largest in the community, had the most surface area losing heat. His fireplace, built proportionally large to heat the space, consumed nearly half a cord of wood daily. By February 9th, Ernst had burned through his entire winter supply and was burning furniture, barrel staves, and anything else combustible. His wife took the children to stay with neighbors whose wood supplies remained adequate. The cold was defeating families that had survived mountain winters for years. Hermann Vogel woke on the morning of February 7th, noted the exterior temperature of 35 below zero in his journal, and added 2 pieces of wood to his stove. The interior temperature was 68 degrees, having dropped from 72 overnight. He made coffee, heated water for washing, and prepared a simple breakfast. The tiny structure's performance during extreme cold exceeded even his calculations. The minimal surface area combined with excellent insulation meant that heat loss, while increased by the severe temperature differential, remained manageable. The small stove, burning efficiently, produced sufficient heat to replace losses and maintain comfort. On February 10th, Otto arrived at Hermann's door in mid-afternoon. His face was gray with exhaustion and cold. He asked, with no preamble or pride, if he could come inside to warm himself. Hermann invited him in immediately. Otto stood in the entry area, shocked into silence. The interior was warm enough that Hermann wore a single shirt. The small stove burned lazily. Frost that had accumulated on Otto's beard during the short walk from his cabin began melting, water dripping onto the floor. Otto asked, his voice hoarse, what the interior temperature was. Hermann showed him the thermometer mounted on the wall, 71 degrees. Otto looked at the thermometer, looked at Hermann, and asked how this was possible. His cabin, with a fire consuming wood faster than 2 men could split it, couldn't maintain 20 degrees. This tiny metal box, with a stove barely large enough to cook on, maintained over 70 degrees. The physics made no sense to him. Hermann invited Otto to sit on the bench near the stove. Otto moved slowly, his body stiff from days of fighting cold, and lowered himself onto the seat with visible relief. Hermann poured coffee from a pot sitting on the stove. The coffee was hot, almost too hot to drink immediately. In Otto's cabin, coffee cooled to lukewarm within minutes of leaving the fire. Otto wrapped his hands around the cup and felt warmth spread through his fingers. He began removing layers of clothing, the interior temperature making his heavy coat unbearable. Hermann waited while Otto warmed himself, saying nothing. After 20 minutes, Otto's color improved, and his shivering stopped. He looked around the tiny interior with new eyes, no longer seeing a cramped coffin, but recognizing an engineered solution to a problem that was killing his neighbors. He asked Hermann to explain, truly explain, how this structure achieved results that seemed impossible. Hermann retrieved his notebooks and walked Otto through the mathematics, surface area versus volume, heat loss calculations, insulation R values, thermal mass behavior, combustion efficiency in properly sized stoves. Otto listened carefully this time, asking questions when concepts weren't clear. Hermann showed him the insulation cavity visible where one interior board hadn't been installed, completely near the ceiling. 4 inches of sawdust packed firmly. Otto felt the interior wall. It was room temperature, not cold like his cabin's walls. He felt the floor, also room temperature. There were no cold surfaces anywhere except immediately around the door and windows. Herman explained that this was the goal: eliminate all cold surfaces that would radiate cold into the living space and create convection currents that made warmth uncomfortable. Otto asked about wood consumption. Herman showed him the wood supply. He had used approximately 1/3 of one cord since November. Otto had burned 5 cords in the same period and was running short. The numerical difference was undeniable. Herman's tiny structure required roughly 15 times less wood than Otto's conventional cabin to achieve temperatures 50 degrees warmer. Otto asked if he could bring Wilhelm and Ernst to see this. Herman agreed immediately. The next afternoon, February 11th, Otto returned with Wilhelm Hoffmann and Ernst Bauer. All 3 men were haggard from fighting cold. Herman invited them inside. The contrast between exterior and interior conditions silenced them immediately. Wilhelm, the carpenter, who had been most vocal in his mockery, stood in the center of the tiny space and turned slowly, examining every detail: the curved ceiling, the insulated walls, the efficient stove placement, the ventilation system. He asked technical questions about construction methods, and Herman answered each one patiently. Ernst asked the question that mattered most to families facing fuel shortages. Could existing cabins be modified to achieve similar efficiency? Herman answered honestly. Modifying a large cabin wouldn't produce dramatic improvements because the fundamental problem was surface area and volume. You couldn't change those ratios without rebuilding. But new construction, using these principles, could keep families warm with minimal fuel. The knowledge was available to anyone willing to challenge conventional approaches. Wilhelm stood silently for several minutes, then spoke quietly. He had been wrong. Herman had discovered something genuinely important, and Wilhelm had mocked him for it. Word spread rapidly through the community that Herman Vogel's tiny structure had maintained temperatures 50 degrees warmer than conventional cabins during the severe cold snap. As temperatures moderated in mid-February, rising to merely 0 to 10 below, rather than the brutal lows of the previous week, neighbors who had dismissed Herman's project began arriving to see the structure and understand how it worked. Herman received them without judgment or satisfaction, simply sharing what he had learned through grief-driven obsession and methodical experimentation. He explained the fundamental principle repeatedly: heat loss was proportional to surface area, not volume. A cabin twice as large had less than twice the surface area, meaning per cubic foot of interior space. Smaller structures were more efficient. Beyond a certain point, adding size created exponentially worse thermal performance. His structure represented the practical minimum size for human habitation. Anything smaller would be genuinely cramped. Anything larger would sacrifice efficiency without providing meaningful additional comfort. The insulation principle was equally important. Conventional log cabins had thermal resistance equivalent to perhaps 2 inches of sawdust insulation. Herman's walls provided 4 inches of packed sawdust, plus the dead airspace between the metal exterior and wooden interior. The total R value was approximately 3 times better than the best log construction. This meant that heat loss through walls was reduced by 2/3 compared to conventional cabins of equivalent size. Combined with the reduced surface area, total heat loss dropped to approximately 1/10 of conventional construction. Wilhelm Hoffmann, examining the structural details professionally, recognized that the techniques weren't complex. The sawdust insulation could be replicated by anyone with access to a sawmill. The curved roof required more carpentry skill than conventional peaked roofs, but wasn't beyond competent builders. The corrugated metal was expensive, but not unobtainable. Everything Herman had done could be replicated by others if they were willing to challenge assumptions about cabin size and construction methods. Ernst Bauer asked detailed questions about daily living in such small space. Was it tolerable? Did Herman feel trapped? How did he manage with so little room? Herman answered honestly. The space was small and required organization discipline. Every item needed a designated storage location. Clutter was impossible. Privacy was non-existent, though living alone made that irrelevant. For a single person, the space was adequate. For a family, a slightly larger version would be necessary, perhaps 12 feet wide and 24 feet long. The principals would scale while maintaining efficiency advantages. The conversation that afternoon in Herman's tiny structure changed how the community viewed both Herman and his project. He was no longer the mad German building a metal coffin. He was a man who had solved a genuine problem through intelligence and determination. Several attendees asked if Herman would help them design similar structures for construction the following summer. Herman agreed without hesitation. The knowledge had cost him his family, months of obsessive work, and significant money. Sharing it freely to prevent others from suffering seemed the only appropriate response. By late February, as winter began its slow retreat toward spring, 3 families had committed to building efficiency shelters using Herman's principles. Wilhelm Hoffmann, swallowing his pride, asked Herman to review his construction plans to ensure thermal principles were applied correctly. Spring of 1888 arrived with the usual relief that followed hard mountain winters, but this year carried an additional element: the quiet spread of Herman Vogel's construction principles through the Colorado high country community. Ernst Bauer began building in late April, as soon as ground thawed sufficiently for foundation work. His structure followed Herman's basic design, but scaled slightly larger, 12 feet wide and 24 feet long, intended to house his family of 5. Herman consulted on the project, helping Ernst understand the critical details that made the difference between adequate and excellent thermal performance. Wilhelm Hoffmann, despite initial resistance, began his own structure in May. His professional pride as a carpenter demanded that he improve on Herman's design where possible. He developed a technique for creating the curved roof ribs using laminated boards rather than steamed single pieces, producing stronger and more consistent curves. Herman examined Wilhelm's innovation and agreed it was superior to his own method. The improvement represented exactly what Herman had hoped for, builders taking his fundamental principles and refining them through professional expertise. By June, 3 more families had begun construction on efficiency shelters. The structures varied in size based on family needs, but all followed the core principles: minimal surface area, excellent insulation, curved roofs, proper ventilation systems, and carefully sized stoves. The community began calling them Vogel shelters, a name Herman neither encouraged nor rejected. He cared only that the knowledge spread and families stayed warm. Mining companies operating in the region sent representatives to examine Herman's structure in July. The companies maintained winter camps for workers at remote sites and lost men regularly to cold-related deaths and injuries. A supervisor from the Clear Creek Mining Company spent 2 days with Herman, taking detailed notes and measurements. He explained that the company operated 4 camps above 10,000 feet elevation, where conventional cabin construction performed poorly. Could Herman's principles work at those elevations? Herman answered that physics didn't change with altitude. Smaller structures with better insulation would outperform large, drafty cabins regardless of location. The mining company commissioned Wilhelm Hoffmann to build 6 efficiency shelters at their highest camp that summer. Wilhelm hired Ernst Bauer to assist. Both men credited Herman openly and insisted the mining company pay Herman a consulting fee. Herman accepted $50, far less than his knowledge was worth, and used the money to improve his own structure with small refinements he had identified during the winter. By autumn of 1888, 11 efficiency shelters stood in the valley where a year earlier Herman's solitary structure had been mocked as a metal coffin. The revolution hadn't been loud or dramatic. It had been quiet, mathematical, and undeniable. Families facing another winter with adequate shelter and manageable fuel requirements understood that Herman Vogel had given them something more valuable than gold: the knowledge of how to survive comfortably in a landscape that killed the unprepared. Hermann Vogel lived in his tiny Quonset shelter for 5 more winters after the brutal cold of 1888. Each winter confirmed what that first severe test had proven. Size was irrelevant compared to thermal efficiency. He maintained detailed records throughout this period, documenting wood consumption, temperature ranges, and structural performance. His notebooks, which he shared freely with anyone interested, became informal textbooks for frontier construction in extreme climates. In 1893, at age 46, Hermann developed respiratory problems that his doctor attributed to the thin mountain air. He sold his property and moved to lower elevation near Colorado Springs. The tiny structure he left behind stood empty for a year, then housed a succession of miners, trappers, and homesteaders who appreciated its remarkable warmth. The principles Hermann discovered spread beyond the immediate community. Mining camps throughout Colorado and Wyoming adopted efficiency shelter designs for worker housing. Trappers building remote cabins scaled down their construction and improved insulation. Homesteaders arriving with limited resources built small, well-insulated structures first, adding larger buildings later once they were established. The cultural equation of cabin size with success gradually weakened as practical experience proved that warmth and efficiency mattered more than square footage. Wilhelm Hoffmann built 17 efficiency shelters between 1888 and 1900, each one incorporating refinements but maintaining Hermann's core principles. Ernst Bauer specialized in insulation systems, developing variations using different materials based on local availability. Both men prospered modestly from their expertise and credited Hermann whenever discussing their work. Hermann himself lived quietly in Colorado Springs until his death in 1921 at age 74. He remarried in 1897, had no children, and worked as a consultant for construction companies occasionally, but spent most of his time in quiet retirement. He never sought recognition for his innovation and declined several requests to write formally about his methods. The knowledge existed in his notebooks and in the structures scattered across the mountains. That was sufficient. The tiny Quonset shelter Hermann built in 1887 stood until 1946 when the corrugated metal finally deteriorated beyond repair. By then, it had sheltered occupants for 59 winters, probably saving several lives during severe cold snaps. Modern tiny house enthusiasts building compact, efficient structures in the 21st century unknowingly echo Hermann Vogel's discovery that size is not synonymous with livability, that efficiency trumps volume, and that thermal comfort depends on physics rather than square footage. The mathematics Hermann worked out in his grief-stricken notebooks in 1887 remain valid. Surface area determines heat loss. Insulation prevents thermal transfer. Small volumes heat efficiently. These truths don't change across centuries. Hermann Vogel proved that rejecting cultural assumptions about shelter size could mean the difference between freezing and thriving. His legacy wasn't carved in monuments or recorded in history books. It was built into the walls and curves of structures that kept people alive when conventional wisdom would have killed them. The impossible had become routine, one tiny warm shelter at a time.